Good morning, everyone. Thank you all for joining me in my session on OAuth with Salesforce. My name is Calvin Norana. I am a technical architect at Blue Wolf. I'm based out of Melbourne, Australia. So last day of Dreamforce, once again, thank you all. Must be pretty exciting for you. Pretty awesome Dreamforce this year, and hopefully this session will also help you to learn a few things. So as part of the agenda today, we're going to discuss mainly OAuth from a Salesforce perspective. So OAuth is a very vast subject actually, and today we're going to limit ourselves in this session to learning key concepts such as authentication and authorization and understanding the distinction between the two. So under authorization, we'll be learning more about OAuth, and we'll understand a few topics related to OAuth, and that will lead us into our first demo, and followed by which we'll then look into authentication, and we'll see something called OpenID Connect, which allows you to do authentication in Salesforce, and we'll see a few things related to that, which will then lead us into our second demo, and then we'll spend a few minutes discussing a certification that Salesforce has, which is related to these topics. And then I request that if you guys have any questions, if you could please park them towards the end of the session. We'll have a Q&A, and if you run out of time, I'm more than happy to talk to you guys after the session as well. So with that, just to set the context of our discussion today, in most of our everyday lives as Salesforce consultants, end users, architects, we usually end up facing a system landscape such as this, where more often than not, Salesforce is at the center of it all, and Salesforce is talking or integrating with different systems. These systems could be based in the cloud, such as Workday or Heroku, or these systems could be on the social cloud, such as LinkedIn or Facebook, or these systems could also be on-premise systems, legacy systems, such as SAP or Oracle, and they could be sitting behind a firewall on a local server. And so users are logging into Salesforce using different types of devices. This could be mobiles, tablets, laptops, computers. So apart from the challenges of the integrations themselves, the other questions to be asked are, how do we determine the identity of the users who are logging into these systems? For example, someone is logging into Salesforce, how is that identity being propagated from Salesforce to the target systems as well? And the other thing that we would need to think about is the permissions themselves. For example, if there's an administrator in Salesforce, and that administrator is logging into Workday through Salesforce, does the administrator carry his permissions or that God mode along with him when he logs into Workday? So these are some of the questions that we'll try to answer as part of our session today. So one of the key things to understand is there's a distinction between authentication and authorization. These are distinct terms. So the analogy I thought would be helpful is the fact of checking into a hotel. So most of us have come from different parts of the US, different parts of the world. We checked into our Dreamforce hotels. So when you went into the front desk, you checked in, you would basically need two things. You would need your ID, which could be a passport or a driver's license, and obviously you need a credit card. But your ID does one thing. It basically tells the front desk agent that you are who you say you are. It's basically trying to determine the identity of the person. So that's what authentication is all about. It's basically trying to identify someone based on a set of verifiable credentials. Now your passport or your driver license has been given to you by some kind of authority figure who can verify who you are, and that's why it's used to identify you. So if you think about this in a client-server terms, the server usually needs to understand who the client is, and the server needs to verify the credentials of the client. So basically, once again, authentication is basically saying you are who you say you are. And in the broader context of computer science, this study falls under something called identity management. So going back, once you actually identify yourself to the agent at the front desk, everything is good, you put down your deposit, you get your hotel key card. So hotel key card now gives you access to your room and other facilities, maybe a pool, a gym in a hotel. And if you compare that with someone like a manager or a security officer at the hotel, that person may have access to different rooms or different parts of the hotel as well, right? So there's a difference in the permissions between your access and somebody else's access. So that's what authorization is all about. It's all about permissions. Does a person have the permissions to access different resources on a server or on a system? So during authorization, there are two things that happen. You either get access or you're denied access based on your credentials. And the key thing to note is authorization more often than not happens after authentication. So once you're identified, that's when people look and see about your permissions, what you have access to and what you don't have access to. And so in the broader context of computer science or technology, this falls under the study of access management. So once again, just to summarize, authentication is basically saying who you are. It is basically talking about your identity, and authorization is basically saying what can you do with this, what permissions do you have. So with that, we'll move on to authorization and OAuth. So most of us are familiar with screens such as these. Left hand side, Salesforce users, you may have seen this screen before, like using Workbench or even Trailhead, for example. So these third-party applications like Workbench or Trailhead, they basically are asking you permission to access Salesforce on your behalf. That's what's happening here. The different permissions being asked depending on how this has been set up, and you have the access to either deny or allow. On the right hand side, another example, Facebook users, we have apps and games. One of the famous games are Farmville 2, where you can farm for carrots, beans virtually. So when you install an app on Facebook, the app basically asks you for permission first, explicitly, saying do I have permission to install myself and access some parts of your profile? And more often than not, we click it, and next day we know it's already posted on our behalf on our walls about our stuff in Farmville, annoying all our friends. So basically what's happening is all of this is OAuth happening underneath the scenes on screens such as these. So the official definition. So right now the official version of OAuth is 2.0, and basically OAuth is an open protocol. So different folks, different companies, different people gather together, and they came up with this protocol that has been agreed upon. And this protocol allows you to securely perform authorization in a simple and standard format. So different systems who are incorporating OAuth, they basically have agreed to this protocol, and they implement this protocol to make two different systems talk to one another. And what this means in simple or layman terms is that if you're a user, you can allow a third-party application or a third-party system to access Salesforce on your behalf without you necessarily exposing a password to that third-party system. You're not giving a password out. That's how OAuth operates behind the scenes. So the question then would arise, why do we need OAuth? So as I said, one of the key things is security. In the olden days of the web, before we had OAuth, a simple example would be if you had a web page and you want to log into Facebook or through Twitter and post there through that website, you would basically need to enter your Twitter or Facebook credentials in that website, which is basically a third-party application. So now what's happening is some other application has your credentials, has password. If it could be malicious or if those credentials are compromised, then you know what happens. I mean, it's a security breach. So OAuth is basically taking you away. It's adding a layer of security on top of it. And also, as you see, end users are abstracted from the inner workings of OAuth. An end user just sees two buttons, maybe deny, accept, and it's kind of easy now to grant access to someone. OAuth is also secure. There's something called SSL, which is secure socket layers. It's basically security at the transit layer. OAuth works with this so that the exchange of information between systems is done in a secure manner. And the other cool thing about OAuth is that access to something can be revoked as easily as it can be granted. So that's the cool part about OAuth. You can revoke this once you're given access to someone. And finally, as a developer, we don't have to store passwords in our code anymore. So I mean, what if the code is compromised, or what if the passwords change, or to go back and do a code change? So that's maintenance. So using OAuth in your code basically takes you away from that and makes you implement OAuth in a better way and in a secure way. So these are some of the key benefits of OAuth. So one thing to understand about OAuth is there's a concept of a flow. The key thing to understand is that for OAuth to work, different systems are talking to each other, and information is being bounced back and forth different systems. There are different types of flows, but this is the general nature of how an OAuth behaves. There are different actors in an OAuth flow, or different entities in a general OAuth flow. You could have the owner, which could be you or me, people who are using an app. Then you have the client application, which could be Workbench, game. You can have the resource server, which is basically or the Facebook. Are you guys able to hear me properly? Okay. Do you know what's happening? Let me continue talking. Hopefully it should work. Okay, so resource server is Salesforce or Facebook, where the data is hosted, and the authorization server is the server who's doing the role of the security. More often than not, the resource server and the authorization server are the same entities. For example, Salesforce different servers, but they are Salesforce themselves. So if you look at our example, Someone is logging into Facebook, they install that game, they try to use the game asks for access. That request then goes through the user and you get the screen where you accept or deny. If the user accepts and allows the app access, that goes into the authorization server. If the server likes the request, the server would then issue something called an access token. And we'll see what an access token is. As of now, think of access token as a key or as an open sesame phrase. So the client application gets that, and then it can access the resource server on your behalf, or it can access Salesforce or Facebook data on your behalf. And from that point on, this is in place, and the application can then access your data. And if you want, the user can go ahead and revoke this permission at a later stage if required. And at that point, the resource server is going to hand off all of the authentication and authorization parts to the authorization server. So in a nutshell, this is how OAuth works. It's basically asking for permissions, and once permission has been granted, there's some data going back and forth systems, and that's how OAuth is implemented. So we spoke about access tokens, and the question would then arise, if you're not using usernames and passwords in OAuth, then what's making OAuth work? How does it tick? So tokens are actually the heart and soul of OAuth. There are different types of tokens when you get into OAuth. So these are used instead of passwords in the OAuth flows. There are three main types of tokens. One is the access token, as we saw previously. The access token has a shorter lifetime. The lifetime is corresponding to the session time in Salesforce, for example. This is basically a session ID. So the end goal of OAuth is to basically get the access token. Once the application has the access token, it can access data on your behalf. There's the other type of token called the refresh token. This is a more longer lived token. Usually in some of the OAuth flows that we see, we have to first get the refresh token, and after getting the refresh token, we can get the access token at a later stage. When you revoke access, you're basically revoking the refresh token. And there's a third type of token called the ID token. We'll park that because the ID token will be used in authentication, and we'll look at that in the second half of this session. So a quick note about Salesforce and OAuth. It's amazing how Salesforce has kept up to date with OAuth. Support began since winter 11, so that's almost 5 to 6 years of support. As of today, there are 8 different types of flows in OAuth that Salesforce supports. We're going to look at one flow in detail, and we're going to look at few other flows at a high level. And the main thing in use case for OAuth with Salesforce is a third-party system or a third-party application can access Salesforce data through the Salesforce APIs using OAuth. So before we jump into what OAuth is, we need to understand the concept of a connected app. So Salesforce has a special kind of app called a connected app, and this is used to facilitate OAuth. Connected apps basically allow you to do authentication, perform single sign-on, and also get the access tokens which are required for OAuth to be in place. As part of connected apps, as I said, OAuth, there's exchange of information happening between different systems. So when a third-party system or the outside application talks to Salesforce, Salesforce needs to know where to send the request back. So that's the concept of a redirect URL or a callback URL. There's also the concept of a scope, which we'll look later, but scope is more of giving fine-grained or fine permissions to a connected app. So once you configure a connected app, you receive 2 pieces of information. One is called the client ID, and the other is the client secret, and we'll look at them in the next slide. For administrators, they can also control connected app access using things like profiles and permission sets, which most of us are familiar with. We can also do IP range restrictions, login hours, 2-factor authentication, and therefore we can control the access of people to the connected apps. So this is how a typical connected app looks like in Salesforce once you've configured it. The consumer key and the consumer secret are given to you by Salesforce once you configure your app, and these are used, for example, in your code to tell your application which connected app to connect to. And then you can see I've selected some of the scopes, which are further permissions that I'm giving my app, and then I've also given my callback URL for where my app should basically talk to my application. So we spoke about those 2 types of IDs, the client ID and the client secret. So the client ID, think of this as the public identifier. This is basically telling your code or your application which connected app to talk to. And one thing I forgot to mention is that every system that uses OAuth has its own version of connected apps. In our second demo, we'll see the Google version of the connected app, and even that has the concept of the client ID as well as the client secret. Now the client secret is a kind of a password value. It's a secret value. We use this only in the OAuth flows which are capable of protecting it. It's giving a higher degree of security, a higher degree of validation that the connected app and the OAuth flow is secure. A quick note about the scopes that we mentioned previously. So once again, scopes, think of these as a further fine-tuning on the permissions that are already configured on your app. For example, in a Salesforce perspective, there are different scopes like API, for example, which basically give your third-party application access to all the APIs that it has access to. And this sits on top of the profiles and permission set security mechanisms in Salesforce. The other types of scopes could be full and refresh token and web. To come back to our analogy of the hotel that we spoke about previously, your room key pass, your scope is limited because it's just your room and a few other facilities. But someone who is in the hotel, like a manager or someone, could have a wider scope than you, and that could be something like a full scope because they have access to other parts of the hotel. So this is how scopes work. It's pretty important to understand scopes in the broader picture of OAuth, because at some point when you're implementing real applications, you need to make sure that your scopes are narrowed down to the least amount of restrictive access that your applications need to Salesforce. So this is a typical access token request. So the way OAuth works under the hood is that there are different URLs, and this URL, for example, we have OAuth2/token. This is the standard Salesforce URL to get the token for a third-party application. And in our code, for example, if you're a developer, we have to construct this URL while writing applications. But the good news is most of us are abstracted from this because we end up using third-party libraries or tools which put a layer on top of this. So most of us are not exposed to this, but it's good to understand how it works underneath the scenes. And as part of this URL, you also can see there are a few parameters that you have to provide to the endpoint. Some of them are client ID and the client secret and the redirect URL where Salesforce can then talk back to your application. This is a typical response. As you can see, the response from Salesforce, if it likes your request, is in the form of JSON. JSON is pretty standard, it's pretty easy to work with. The main piece of information obviously is the access token. Once again, the access token is the end game of OAuth. It is what OAuth is there for, to get your access token. There are other things, for example, the signature, which was used to encode the response, and the time at which the response was issued to the application. So these are some of the different flows in Salesforce, and we'll take a deep dive into web server flow, which is because that's the most common and important flows out there, and we'll have a high level look at some of the other flows that are listed here. So web server flow, as the name suggests, this is used by any web server application that is needing to talk to Salesforce. A good example would be LinkedIn or Fitbit. These applications would use the web server flow, and the key thing to note obviously is that because these apps or these applications are running on a server, they are more inherently secure. That means you can actually store your client secret in these apps. They are less susceptible to be hacked or to be compromised. So again, the use case for a web server flow is when you have a third-party application or a system which is sitting on a web server, and that system wants to talk to Salesforce on your behalf. That's when you would use OAuth and implement the web server flow to facilitate that system talking to Salesforce. So this is at a high level how the flow actually works. So you have the client application. Once the user starts using the client application, it will redirect the user to the authorization endpoint of Salesforce. At that point, if the user is not logged in, the user has to explicitly log in, and then you get the page where you have to approve or deny. So if the user goes ahead and approves the request, Salesforce is then going to send an authorization code back to the client application, at which point the client application would then use that to request the access token to the token endpoint which we saw in the previous slides. If Salesforce likes that request, it's then going to go ahead and grant the access token to your application. And as I said, the access token is the endpoint or the end game of the OAuth flow, at which point your application at step number 6 can access all your protected resources in Salesforce. So this is how a typical web server flow behaves. Then a quick note on the other flows that we mentioned, but which you're not going to look into detail. We have the user agent flow. This is used when you have a client-side mobile or a browser application, and this is sitting in a local device somewhere. That's when you would use the user agent flow. Because these devices can be compromised, you cannot use the client secret, so these flows behave differently. Then you also have the username password flow, or it's also called the autonomous flow. Salesforce usually frowns on this flow because, as the name suggests, you are basically embedding the password as part of the OAuth request, and these are used for applications that do not require any explicit user interaction with the applications. And then you also have the SAML bearer assertion flow. For those of you who have worked with single sign-on, and single sign-on is a concept where you can use one set of credentials to log into another system. For example, you can use your Workday credentials to log into Salesforce and vice versa. If you used it, you may be familiar with something called SAML, which is one of the languages used to implement, or protocols used to implement single sign-on. If you have that with you, you can also use that. You can reuse that to put it into a special kind of flow called SAML bearer assertion flow to get your OAuth authorization token. Similarly, if you are doing server-to-server integrations using JWT or JWT or JSON Web Tokens, you can also reuse that to get OAuth tokens using this kind of flow. So with that, we'll move into our first demo. This is a very simple demo which I put together. What's happening here is that I've created a simple web page on Heroku. This web page is going to use the web server flow which we mentioned. I'm making use of a third-party library called ForceDK to abstract the OAuth flow. But then I'm going to display everything that's happening behind the scenes for us to see how the flow is working. And then just to ensure that it's working, we are going to query Salesforce using a SOQL query and just fetch the last 20 modified accounts from Salesforce. So let's go and see that. So give me a word, this was working previously, so I'm hoping it works again. So this is the web page. This is hosted on Heroku. There's a simple button here, so clicking this should initiate my OAuth flow. It is calling the authorized endpoint. So this is my connected app which is calling this behind the scenes. So I'm going to go ahead and allow this. So after this, we see two more buttons here. The first is the OAuth info, where I'm printing the response and the underlying things that happened. So as you can see, my app, the very first thing it did was it made a call to the authorized endpoint, and it sent it a bunch of parameters, which includes the client ID and the redirect URI. Salesforce apparently liked this request, that's why it responded, and it gave my application the authorization code, which is the precursor to the access token request. So once my app got that, it then made a subsequent request to Salesforce to the token endpoint by passing this. And once that was made, Salesforce liked that request, so it responded and it gave me the JSON, which I have kind of parsed and I have displayed it here. So the most important thing obviously is the access token or the session ID, which my application now has. And then there's a bunch of other information being sent, like the instance URL, which points to my developer org, and obviously the time at which this request was sent back. And looks like the time is still in Australia. Okay. So a quick look at the connected app itself. I'll refresh that. So this is the connected app I put together. Again, this is the consumer key, the consumer secret. As you can see, it's a smaller string. And all of these two pieces of information was created by Salesforce automatically once I created my app. I also have given a bunch of scopes, and I also have configured the callback URL, which is basically my application sitting on Heroku. And the other thing to note is if you go to the manage section of a connected app, there's something called the OAuth usage button, and there you can see a few things, and you can also see my app is sitting here. You can see the block action where someone can actually go and revoke access to my app, and you can also see the use count, 68, which probably tells you how many times I've rehearsed this probably. So that's a brief note about the connected apps themselves. So let's quickly look at the code. Pretty simple actually. So this is the main HTML file which I had. So it's doing some of the display information. In the JavaScript section, I'm just creating the different parameters which I'm sending to my code, which does the OAuth. You can see here that I have instantiated the ForceDK client, and ForceDK is pretty awesome. Check it out. It allows you to do OAuth pretty easily with code. The main thing I'm doing here is to create the authorized endpoint. I'm constructing it in my code. I'm passing all the parameters that I just passed it. And once that goes into the ForceDK layer, it's then taking over, and it's then handling the rest of the OAuth mechanisms. The other important thing is once Salesforce actually receives the request, it calls my application back at this HTML page, And in the JavaScript here, all I'm doing is I'm just taking that URL that Salesforce sent me, I'm parsing it, I'm fetching the access token from there, and I'm then injecting that access token back into my code here. And this is the SOQL query we ran. We are just trying to fetch the account information. So if you go back here to my demo, this is the place where we actually fetch information from Salesforce. So you can quickly go and see if this works. We can go and do just a quick edit on an account. We'll just call this demo 17. I'll just restart this again. I'll allow that, and so this is basically retrieving it based on the descending order of the last modified date, and you can see that the latest information has been pulled out in a almost near real-time fashion. So that's the demo, guys. So we'll go back and look at what authentication is now. So if there's one thing we learned in this session, it's that OAuth 2.0 is all about authorization. So that once again, OAuth 2.0 is all about permissions and seeing what a user or a third-party application has access to in Salesforce. So authentication, as we mentioned, is all about someone's identity. If you used single sign-on previously, you may be aware of something called SAML. So there's this new concept called OpenID Connect. It is basically an alternative to SAML, and it helps you do single sign-on. OpenID Connect, think of this as OAuth 2.0 plus identity. So it's an identity layer which has been placed on top of OAuth, and this allows you to do single sign-on into Salesforce. So basically, this is an hybrid of authentication and authorization, and it's amazing how Salesforce is using this quite frequently and quite across the board. You can also connect to different Salesforce Salesforce instances from a different Salesforce instance using OpenID Connect. So there's a lot of support for OpenID Connect both from Salesforce as well as other big players in the industry, including these guys, PayPal, Facebook, Amazon, Microsoft. All of these are OpenID providers, so it's a pretty good technology to learn. Some of your PayPal transactions, when you do that, it incorporates some facets from OpenID Connect as well. So one of the other questions that could arise is, why can't we use OAuth 2.0 for authentication? So as we mentioned once again, and there has been some dispute about this, but the way I would look at it is to understand the protocol. The OAuth 2.0 protocol has not been designed for authentication, it has been designed for authorization. And the end goal of OAuth is to basically get the access token. And if you understand, the access token does not represent someone's identity, it only represents their permissions. So therefore, we can't use OAuth for authentication. That's where OpenID comes in, because along with the access token, as you can see in OpenID, we'll also get the ID token. And the ID token represents someone's identity, and that's why that is used for authentication and not OAuth by itself. So this is how the OpenID Connect protocol works. It's similar to how the OAuth 2.0 protocol works. Again, the client application request service, so there's a redirection happening. If the user is not logged in, he'll be asked to authenticate and authorize the client, the accept versus deny. If the user allows the application to access Salesforce, at step number 4, it's still the same thing. It's redirected back with the auth code. At that point, step number 5, we are still the same thing. The application is then going to request the token using the auth code. In step number 6, there's a slight change now. The response now includes the ID token along with the access token. That's the fundamental difference between OpenID Connect and OAuth. Using that now, the application can request the user information, and what this allows the application to do is then to verify that the credentials of the user match who the user is saying he or she is. And that's how the authentication bit is happening as part of OpenID Connect. So this is a typical OpenID Connect response. Again, this is JSON. Some of it is similar to what we saw in the OAuth 2.0, but there's one big giant chunk. It's called the ID token. So any client application which is using OpenID Connect, behind the scenes, underneath the hood, the client application will basically decode that chunk, and that is going to decode into something like this. And this here, the important thing is the AUD or the odd or the audience parameter. Any system which is implementing OpenID Connect would then look at this, and this has to correspond to the client ID which is configured in the connected app. So that's how the third-party application knows that this is the person who initiated this whole transaction for a final checks and balances of the whole transaction. So then let's go into demo 2. This will be a quicker demo. Here what I'm doing is I'm doing a social sign-on. It's a form of single sign-on. I'm going to use my Google credentials to log into my Salesforce developer org, and we'll see how we set this up. I use something called an authentication provider in Salesforce. It's more of clicks, not code. There's just a small Apex class as well, and we'll look into how that works. So let's go and see that now. So I'm going to go back to Salesforce. I'm going to log out of my administrator profile. I'm now going to log in not using my Salesforce credentials, but using this here. This says Google Auth Provider. This is something that I named. I'm going to click that. Apparently, I have a bunch of Google accounts. I'm going to use the second one, which I've configured to use this. Hopefully, this should work. Something happening behind the scenes. And as you can see, I use my Google credentials to log into Salesforce. So the main use case here is you could have a community, and you don't want folks to use a Salesforce credential. On your communities, you can make people to use their Twitter or Facebook or Google credentials and log into a Salesforce community. That's the main use case of this. So now if this user, the Google user, if I try to log in and if I try to search for auth provider, nothing is going to show up. It's because I'm not logged in as an administrator, and we'll see why that's the case. So I'm going to log out of this now. I'm going to log in again as the administrator using my Salesforce credentials now. So we can take a look at the auth provider. So as I mentioned, every system that uses OAuth or OpenID has their own version of a connected app. So this is my Google version of the connected app. This is Google's connected app, and this is in the Google console. This is what I set up, and it has given me its version of the client ID and the client secret, which I have taken and conveniently plugged into the auth provider here. And this is how my auth provider knows which Google console app to connect to. There's nothing that happened. All the back and forth stuff that happened was taken care by Salesforce. I didn't do anything about it. It was all abstracted for me. The only other thing is the registration handler. This is basically a piece of Apex code that does the processing of everything once the OpenID Connect protocol has taken place. So let's have a quick look at what it does. So here what's happening is, as you can see, I have assigned the standard user to the internal profile. That's why when I logged in as my Google user, I was not able to perform administration duties because my profile that was assigned to me was basically the standard user. So I'm not going to show all the code, but at a high level what the code is doing is basically seeing if the email of the user exists as a contact, then it's going to use that email and see if there's a corresponding user attached to that email and use that to log into Salesforce. And if not, it's going to create the user and the contact on the fly, and then assign the standard user profile to that user. And this is called user provisioning, wherein users are created on the fly in real time to access a different system. So quickly we'll go back to Salesforce, and we'll see that this is the user here who was created. This was my a Gmail account that I used, and this is the username that Salesforce created for me on the fly. Looks like it appended something which is standard, and that's how it distinguishes me from the rest of the users in my org. And the last thing we'll see is once I did all of this, the last piece of config was we have the concept of my domain. It is Salesforce's own custom domain that you use to uniquely identify your instance. So I just created something like this, which is basically here as well as a precursor to my URL. And here under the authentication configuration, I just went and said display the Google Auth provider as well in addition to the Salesforce page. So as you can see, this will probably take you 20 to 25 minutes to set up. Even the Apex code is given to you by Salesforce. I got this from Trailhead and made a slight modification. So you have working boilerplate code, and you can take it and modify it to suit your needs. And Salesforce has samples for Google, Facebook, and I think Twitter as well. So that's pretty easy to set up. So as you can see, it's pretty easy to set up using just some clicks, someone to log into Salesforce using a third-party credentials like Google or Facebook. So with that, we'll go back to our presentation. The last thing I wanted to talk to you about was the Identity and Access Management Designer Certification, quite a mouthful. So if you are interested to be a system architect or a certified technical architect or a CTA, this is one of the exams that you have to pass now to get to that stage. This exam basically is all about authentication, authorization, some of the concepts that we touched upon in this session, and mainly with a emphasis on single sign-on. It also talks about some of the different Salesforce identity features. We looked at some of them today: connected app, my domain, auth providers. You have to go into a little more detail of that and know them, some of them in and out. The OAuth 2.4s are very important. We saw one flow today, and that was the web server flow. And the main thing to understand here is what are the different flows and why they're needed, what are the distinguishing factors between them, and what are the different use cases for these different OAuth 2.0 flows. And that's covered, and that's almost 40% or 30% of this exam. And finally, it also touches upon some of the things that we could not look into a lot, great deal here. Things such as two-factor authentication, high assurance sessions, IP range restrictions, IP login hours, all of the stuff related to security, that plays an important role in this exam as well. Some folks do think this exam is hard, but it's not. It just needs a good understanding of these concepts, and I think you should be well set to take this exam. I took this exam, passed it, I wrote a blog, some folks deemed it to be useful, so I added a link there just in case someone wants to check it out. Any questions, you can definitely reach out to me at any time, but it's a great exam to get, and once again, it covers some of the concepts that we touched upon in this session. The last thing I want to do is some of the links that I found useful during my studies. I've kept this up for you for a few moments so you can get a picture of this. Some of the things are further learning about OAuth. So the goal of this session was just to establish the foundations of OAuth and authentication and authorization with Salesforce. So these things will help you to further learn on your own in case you are interested in these things. Some of the cool things is the tutorial about integrating Salesforce and LinkedIn. It is a step-by-step tutorial, so definitely try that out. And last but not least, Trailhead. The very last link is the Identity and Access Management Trail. It's pretty awesome, lot of cool trails out there to learn these topics, so definitely check them out if you haven't done so. And with that, I think I should be done. So if there are any questions, please feel free to come to the mic and shoot away. Thank you all. Okay. Thank you, guys. Yeah.
So if you're trying to debug your OAuth flow, what are some tips of debugging? Because sometimes it can be pretty frustrating. You just get session ID expired or something, and what do you check first?
So that's a great question. So personally, the way I've done this is I use a tool like Workbench or Postman to kind of break down the URL. So example, if I usually work with the web server flow. And the web server flow, as you know, there are two endpoints. One is the authorization endpoint, and one is the token endpoint. So I try to manually construct the authorization endpoint myself and plug it into Postman or some other tool which basically does the HTTP call-in into Salesforce, and that usually ends up giving me the answer that I'm looking for, like an error, and that kind of helps me to then go on the right path and continue debugging the issue.
Thank you.
Hi. When I've looked in login history on a user record, particularly for user accounts that I've assigned to integrations, I noticed that some of them will list the application that they are and others will not.
Okay.
Is that one of the, is OAuth the reason why some show that it is this particular application logging in, whereas others just show nothing?
Okay, that's another great question. I think in the login history, what happens is we are logging the user who is logged in, basically, and some of these applications, they end up using a user from your org, or they end up using a user that they have created as part of the package. So I'm assuming that this problem that you're looking at, the application maybe is using a user that it created as part of the package that you installed in your org. So that's what I'm thinking. I'm not really sure. It's something that we'll need to look into.
Okay.
But the login history basically is corresponding to the user who is basically performing the flow. It could be someone from your org, which the application is piggybacking on, or it could be someone that the application is creating itself as part of the installation package.
Doesn't answer the question, but I will talk to you afterwards about it rather than taking up everyone's time.
Yep, thank you.
Hi. I actually have an application outside of Salesforce, and they want to provide access like a tab in Salesforce. When you click on it, a single sign-on into their app. So Salesforce is actually a authentication provider, not the other app. Can I use OpenID to do that?
I think you can definitely use OpenID to do that. So if I understand use case again, you're saying Salesforce is the identity provider.
Yeah.
And you're trying to single sign on into a third-party application using Salesforce.
Yes.
Yes. To do that, you can use OpenID, but your application should also then be able to implement OpenID and use behave as a service provider for Salesforce.
So, but then they already log into Salesforce. I think with OpenID, it pop up another login, and then you have to log in. Can we bypass that because I already have a Salesforce session?
Okay.
Right. So to simplify it further, if I click on it, I know with OpenID you can just pop up a message, and I have to open it, click it again.
Yep.
It doesn't make sense. It's an extra step because they already inside Salesforce and they have a Salesforce Sessions ID already.
Okay.
What's the best way to seamlessly single sign on them into the other app, right? Well, would you be able to bypass that?
I think you may be, and I probably need to understand this a little better, but I'm thinking using code, we could probably do a check and see if you already have the session ID, and if you have it, then don't perform the OpenID or the OAuth flow, and instead use that and continue working in your thing. We probably need code to bypass it.
Okay.
That's what I'm thinking off the top of my head, yeah.
I see. Okay. Thank you.
Yeah. Okay. I think we're out of time. If there are any questions, I'll take them on. Thank you guys so much. Appreciate it.